Alright, let's look at the homework 3.3, problem number 10. Alright, so let's evaluate the limit of s over d in this figure as theta approaches 0 from the positive side. Alright, so let's do that. So s is the arc length, so we don't know, well, let's see, there's no radius given, so I'm going to just give a radius. So let's say radius is r. Right, so we know that the s is the arc length, so s is going to be equal to radius times the angle in theta, so it's going to be r theta. Alright, so d, we have to come up with d, so I'm going to just split this in half. Right, so this way we have an angle, so this is going to be theta over 2. Alright, so half of the d. Alright, so maybe we should use, let's say, sine. So we know that the sine of theta over 2 is, right, sine is opposite over hypotenuse, right? So opposite in this case is half of the d. So d over 2, right? And the hypotenuse is the radius, so this is going to be just r, right? Then if you're looking for d, we can just solve for d. So this is going to be, right, so I'm going to multiply both sides by r, so you get r sine of theta over 2 is equal to d over 2. Then we can multiply both sides by 2 to get the 2r sine of theta over 2 is equal to d, because 2 cancels out. Alright, so we have s in terms of theta and also d in terms of theta. So let's put that in. So we're looking at the limit of s. S is going to be r over r times theta, and the d is 2r sine of theta over 2. Right? Then as theta approaches 0. Right? So first thing we do is that since the r on top and r on the bottom, so we can cancel those out. And then I'm going to divide top and bottom by theta. So you have a 1 over theta on top, and I'm going to multiply by 1 over theta. Alright, so if you do that, you're going to get limit as theta approaches 0. Right, then you would have theta divided by theta, so that'll be 1. And then you have a 2 is still there. And you have a sine of theta over 2 over theta. Right? Then we have to make this adjustment. We're gonna, let's see, divide the bottom right here, so I'm gonna divide this guy by 1/2, so it's theta over 2, because I want to match this theta over 2 there. So if you divide the denominator by 2, we have to divide the numerator by 2 as well, so you have a 2 divided by 2 here. Alright, so this way we're not changing anything, but the good thing is we can cancel those 2's. Alright, then we know that as theta approaches 0, this guy right here approaches 1, according to the useful limit. Then we have a 1 over 1, so this limit is going to be 1. Alright, so let's double check, and let's see, limit is going to be 1. Alright, so submit for testing. Alright, it came back and looks like we got this one correctly. Alright, that's it. I hope that this was clear.